Hello, friends. Nice to have you today again in mathematics class. So, welcome to another interesting episode of mathematics class. Please stay tuned and enjoy the class. So, just a few minutes of recap. In previous classes, we have been able to consider the concept of number base. What is number base? We also went further, talk about the various unique forms of number base we have in mathematics, like the base 2, otherwise called the binary, base 8 called the octenary, base 10 called the decimal or ternary, the base 12 known as duodecimal, and we also consider base 16 talking about the hexadecimal. And thereafter, we were able to convert from base 10 to base 2. And so, in today's class, we're going to be considering how to convert from base 2 down to base 10. But don't forget this principle that in order to convert from a higher base to a lower base, you must divide to get there, putting the remainder into consideration. And then now, if you must convert from a lower base to a higher base, you have to multiply, or simply put, you expand to get to a higher base. So if I was to convert from base 2 or base 6 or base 7 or base 8 to base 10, I must use or apply the principle of expansion. In other words, multiplying together. So quickly, let's consider conversion of binary to denary or decimal. In brackets, you can write decimal. That's another name for base 10. So let's consider example 1. If you were given a question like, let me see example 1 first. And the question says, convert 11110 base 2 to denary or decimal. If you are given a question like this, what do? It's as simple as ABC. Simply apply the principle of expansion. You can as well, okay, before then, let's say solution. You can quickly assign powers to them, starting from the last one here 0, 1, 2, 3, and 4. That is going to be the power, but don't mind, we'll understand it in a little bit, in a little while. So let's say you take, how do you expand or convert from base 2 to base 10? Simply take the first digit, multiply with the base, take the power. Take the first digit, multiply with the base, take the power. So what do I mean? I mean, you writing, take 1, the first one here, multiply with the base, raise to the power, or simply count the remaining ones, which is remaining digits. 1, 2, 3, 4. It applies that the remaining digit is 4, which coincides with 4. I wrote before. So the next value will be also 1 times the base again, multiply with 2, raise to the power, which is 3, or simply count the remaining digits. I said, take the digit, take the digit here, multiply with the base, count the remaining digits, which is 3 in numbers. Write 3 as the power. Plus, the next digit is 1. Bring down the 1, multiply with the base again, count the remaining digits, which is 2. 2. You write 2 here. Plus, the next digit is 1 times the base again. Then the next power after 2 is 1. Plus the next one is 0 times the base again. The last power is 0. Now let's observe something here. A close observation will tell you that these powers were decreasing one step at a time. You can see 4, 3, 2, 1, and 0. It must continue decreasing one step at a time like that, and it must correspond with the initial powers you wrote on top of the digits you're given. So what happens? We say 1 times, if you multiply 2 times 2 times 2 times 2 into 4 places, you're going to have 16. What do I mean? 2 raised to power 4 means 2 into 4 places, which is 2 times 2, 4. 4 times 2, 8. 8 times 2 gives you 16. So you write 16 here. Plus 1. Do the same thing. 2 raised to power 3 means 2 into 3 places, which is 2 times 2 times 2 gives you 8. So 1 times 8 plus 1 times 2 raised to power 2 is 4. So I'm going to write 4 here plus 1 here. Bring down the 1 times 2 raised to power 1 is 2 plus 0 times. Get this principle in mind. Anything raised to power 0 in mathematics is 1. Even if it is 1 million raised to power 0, 1 billion raised to power 0, it is still 1. Even alphabet like A raised to power 0, B raised to power 0, it is still 1. The principle is anything raised to power 0, it is 1. So we say 2 raised to power 0 gives you 1 right here. So having done that, 1 times 16, 16 plus 1 times 8 is 8 plus 1 times 4 is 4 plus 1 times 2 is 2 plus 0 times 1 is 0. So let's add our values. 16 plus 8 gives you 24. 24 plus 4 gives you 28. Now 28 plus 2 gives you 30. Now you now conclude by writing the final answer, which is, write the question first, which is 11110 base 2. When converted to base 10 gives you 30. Then you write 10 here, or write it in words. You can write the 10 in words, which is T-E-N. It's as simple as ABC. The principle is what you have to store in mind, that if you're converting from a higher base to a lower base, you must divide, as like we did in our previous classes. And thereafter, if you must convert from a lower base, be it base 2, base 3, base 4, base 5, base 6, convert it to a higher base like base 10, you must use the principle of expansion to get there. Even if I'm converting from base 6 to base 10, the same principle is being applicable. So take note of it. Now, let's quickly take another example in regard to this. Let me clean up with this. So, if we are told to convert 11001011 10101, and it was given in base 2, so base 2 to decimal or ternary, the same thing, don't forget it. So what do we do? The principle is apply the principle of expansion, or multiplying by the base to get there. What do I mean? The solution will be this. Take the first one, the first digit right here, bring it down, times, like I said, during the last example, I said you can assign 0, 1, 2, 3, 4, 5, 6. Even if you don't assign it right from the initial state, it doesn't matter. You can as well do it from the natural perspective of saying, take the first digit, multiply with the base, count the remaining digits. 1, 2, 3, 4, 5, 6 gives you 6. Plus, the digit is 1, 2. 1 times. If this power is 6, it means that the next power is going to be 5. Multiply with the base, write 5. Plus, the digit is 0. 0 times the base, raised to power 4. Plus, the next value of digit is 0 times 2 raised to power 3, plus the next one is 1 times 2 raised to power 2, plus next one is 0, which is this. this now. 0 times the base again. Sorry. 0 times the base. Then what is the power there? Is 1. Plus, the next one is 1 times 2 raised to the power 0. Nothing is left. After taking this, nothing is left. So the power is going to be 0. A close observation will tell you that the powers are decreasing one step at a time, reducing by 1. So what do? We say 1 times, take a close look at this. 2 raised to the power 6 means 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. 2 raised to the power 6 means 2 into 6 places. It is not 2 times 6. But 2 times 6 will give you 12. But 2 raised to the power 6 will not give you 12. So what do? We say 2 times 4 gives you 4. 2 times 2 instead gives you 4. 4 times 2 gives you 8. 8 times 2 gives you 16. 16 times 2 gives you 32. And 32 times 2 gives you 64. So right here we have 64. 64 plus 1 times 2 raised to the power 5 will give you, take this 2 out. So 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2 gives you 32. So here will be 32. Meaning 2 raised to the power 5 is 32 plus 0 times 2 raised to the power 4. 2 times 2 is 4 plus 0 times 2. Sorry about that. 2 times 2. Cancel this. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So right here we have 16 plus 0. 2 raised to the power 3 means 2 times 2 times 2, which gives you 8. Plus 1 times 2 raised to the power 2 gives you 4. Plus 0 times 2 raised to the power 1 is 2. Plus 1 times 2 raised to the power 0. Take, like I said before, anything raised to the power 0 it is 1. Even if it's 1 billion, 1 million, it is 1. So 2 raised to the power 0 is 1. Why not 1? Let's erase this. So we proceed. 1 times 64 is 64, because anything times 1 is that value. Plus 1 times 32 is 32. Plus 0 times 16 is 0. Plus 0 times 8 is 0. Plus 1 times 4 is 4. Plus 0 times 2 is 0. Plus 1 times 1 is 1. So 16 plus 64 plus 32. 64 plus 32 will give you 96. 64 plus 32 gives you 96. You can do a proper arrangement like this. 64, 32 gives you 6, gives you 9. So it is 96. Then plus 0 plus 0 is 0. Plus 4 plus 1. So 96 plus 4 gives you 100. 100 plus 1 gives you 101. Don't forget, for the fact that this is 101, it's not automatically in base 10, because after a conversion, it's supposed to be in base 10. So 101 is not in binary in this case. 101 in this case is in base 10. In base 10. In base 10. Don't forget it. So we come to a conclusion by saying, we write the answer, the question first, 1100,101, being in base 2, after conversion, give you 101, which is 101 base 10. As simple as that. That brings us to the end of this segment or this episode. See you over in the next class. Thank you.